In this video, we are going to do a problem that is similar to question number 10 in homework 11.2. The directions are to solve the equation either by factoring or using the quadratic formula, whichever is more appropriate, and to, of course, simplify our answers. Now, number 10 is baiting you, right? I see sets of parentheses, and I want to go like this. This is going to be a mistake. I want to go, oh, set that one equal to 0. This is a mistake. They're baiting you. Set this one equal to 0. X is positive 2. Submit. We got that wrong. Why did we get that wrong? There's only something special about the number 0, right? And over here on my right hand side, I have -4, which is a non-zero number. It's important to get it. It's only useful in factored form when it's set equal to 0, so that we can use the zero product property. So to do this problem, you actually first have to multiply out the entire left-hand side. Then go ahead and add 4 to both sides so you have a 0 on the right-hand side. Then factor it. So we're going to do, I don't want to do this exact one, but I want to do a similar one. All right, so this is similar to problem 10. It would be a mistake to say, oh, x is 5 and x is -1. Why? Because this is not 0. Right, so first I'm going to go ahead and multiply everything out. X times x is x squared. X times 1 is 1x. -5 times x is -5x. And -5 times 1 is -5. And this is helping a lot of us. I'm going to keep highlighting my equal sign. There's some like terms for me to combine here. We've got x squared. 1x minus 5x is -4x. All right, and now I'm ready to go ahead and set this equal to 0 by subtracting 3 from both sides. All right, so we have, and I'm going to drop the color here, we have x squared minus 4x, and then here are some like terms. -5 minus 3 is -8, is equal to now 0. Yay! All right, oops, highlighter. Bloop. Right, so now we've got it. What we just did right here is we set this equal to 0. All right, so I'm happy here. Now we're going to go ahead and factor, if we can. And if we can't, we'll use the quadratic equation. Because my leading coefficient is a 1, we have a 1x squared here, I don't need to do the full-on AC method or much trial and error. I know a certain amount of the story already. I know that x squared came from an x times an x. Now, what are the options for me to run through? I'm looking for things that multiply together to give me -8. So I know one is negative and the other is positive. A minus times a plus is a minus. And then things for 8, we've got, -2 times 4, positive 4 would give me -8. Switching those around would not change anything because we've got the same beginning here. Right, so the order doesn't matter, but we could have the 2 be positive and the 4 be negative. And then we could have a -1 and a +8. Or we could have a +1 and a -8. Those are my only options. And if this fails, if these 4 options fail, then we've got to use our quadratic formula. Let's try this first one. Right, we know that x times x gives me x squared, and we know the minus 2 times 4 gives me minus 8. We did that on purpose, but what about the combining the like terms step? X times 4 is 4x, and minus 2 times x is minus 2x. 4x minus 2x is 2x, and that's not equal to what I need. I need minus 4x. So it's not this one, right? This was a fail. What about if the 2 is positive and the 4 is negative? Well, does that help me? We now have a minus 4x plus a 2x, which is minus 2x, and that's not working either. That's not equal to minus 4x. And I know I said x, but I'm looking at my writing here. I didn't write an x. Okay, so we know it's not that pairing. What about the minus 1 and the positive 8? X times 8 would be 8x, and minus 1 times x is minus x. 8x minus x is 7x, and also a fail. That's not equal to your minus 4x here. All right, I just decided to help ourselves with the color, right? I'm looking to combine. When I multiply this all out and combine like terms, I'm supposed to have a minus 4x, and we aren't having that. The orange was a fail too. All right, what about x times, I have to change it. The last one, if x is positive 1, x plus 1, we do the plus 1, and then we do the minus 8. What's going to happen there? X times minus 8 is minus 8x. 1 times x is plus 1x. Minus 8 plus 1 is minus 7x. Also a fail. That does not equal our negative 4x. So this thing is not factorable. We need the quadratic formula. And some of you might have just wanted to jump in with that right away. This is not factorable. We need the quadratic formula. All right, so I just took our problem and wrote it right here. What do we need to do to use the quadratic formula? Well, it needs to be set equal to 0, check, and we want to have it with the x squared term, the x term, and the number term in that order so that we can identify A, B, and C. In front of that x, there is in front of that x squared, there is a 1. Right here, A is 1. B is, don't make this mistake and say it's 4. That minus belongs to it. B is negative 4. A is 1. B is minus 4. And don't make this mistake. C isn't 8. C is minus 8. All right? So we've identified A, B, and C. Here's my quadratic equation. You do not have to write it like this, but this is my way of writing it to help students that have a hard time. We all understand replace all the A's with 1s, the B's with -4s, and the C's with -8s. But the difficulty is simplifying that whole thing after you've done it. And if we plug in this way, it helps a lot of us. That's our quadratic formula. So I'm going to go ahead and plug in these numbers. X is equal to the opposite of B. That's a -1 times B, and B is -4. Plus or minus, there's two answers here, and if you don't like looking at the plus or minus, I'm graying it out. If you don't like looking at the plus or minus, remember you can just work with the plus, and after you've done all your simplifying, remember, oh yeah, there's two numbers here. But just, if you do that, just don't forget the square root of B squared. B is -4. That whole thing is being squared. So that's a -4 times a -4, which is +16. A common mistake is to write -16. And then instead of writing -4AC, I'm going to just write plus a -4 times A. Our A is 1, and our C is -8. Get some color here. A is 1, and C is -8. All over, meaning divide this whole thing divided by 2 times A, and here A is 1. Okay, so now it's time to simplify, right? Here we are, and we plugged in, and now it's time to simplify. The solutions, the numbers that make that original statement true, are a -1 times a -4 is +4. Plus or minus the square root of -4 squared is a +16. That's -4 times -4. Plus, and then what's this answer? -4 times 1 is -4 times a -8 is a +32. All over 2 times 1, which is 2. This illustrates also why I kind of like writing it like this. If you had -4AC, you'd have -4 times A, which is 1, C is -8. You'd have minus a minus, oops, yeah, we'd have minus a -32, which is +32, and that can get a lot of people in the simplification of minusing a minus is plus. When you get really comfortable with this formula, you won't do this. When I plug in, I just go for it because I know how to read those operations, but it just takes a ton of practice. So this is my recommendation for you. Okay? So now we're almost there. It's now time to simplify completely. We've got 4 plus or minus. Don't make this mistake and go, oh, I'm excited about the square root of 16, that's 4. We have to do this addition first. There's always going to be a perfect square just sitting right there because the quadratic formula has a perfect square sitting there. So 16 plus 32 is 48. And now I need to ask myself, and maybe I do a little bit of scratch over here until you get good at simplifying these roots. Sometimes it's hard to do that simplification in the whole problem. 48 has a 4 in it. Maybe it has a larger perfect square factor, but what if we just see the 4 first? 48 divided by 4 is 12. Oh yeah. This is the square root of 4 times the square root of 12. The square root of 4 is 2 times the square root of 12. But the square root of 12, we're not done. I didn't actually find the largest perfect square factor that went into 48. I just found one of them. So if I notice here that 12 is 4 times 3, we've got 2 times the square root of 4 times the square root of 3. We have 2 times 2 times the square root of 3, which is 4 times the square root of 3. I think that's real nice to have that little bit of scratch off to the side here. Oops. Okay, so that square root of 48 is 4 root 3. So I'm going to put it in. And we're super close, but we're not totally done. We got 4 plus or minus the square root of 48, which is 4 times the square root of 3 all over 2. And we are not done. Why? Let's rewrite this problem without color right down here. X is, and maybe we break this up into x being 4 plus 4 times the square root of 3 all over 2, or x is 4 minus 4 times the square root of 3 all over 2, and put it back together after. That plus or minus can just visually cloud our mind. Okay, so all I've done is I've split this sucker up. And the reason why I'm not done is that 4 and 2 all have a common factor, right? 2 is a common factor. There is a secret times 1 in here. And I'm going to write it 2 different ways. One, I'm going to go ahead and factor out that 2 in my numerator. 2 times 2 times 2 plus 2 square root of 3. Let's see it. 2 times 2 is 4. Check. 2 times 2 is 4 times the square root of 3 is 4 times the square root of 3. Check. I've factored out that 2. And right here, I'm not canceling 2's, I'm acknowledging a secret times 1. So we've got 2 plus 2 root 3. Okay? Another way, this isn't any different except there's a minus sign there, but sometimes factoring out that 2 looks a little strange to people. So here I'm going to write it like this. Are these equal? They sure as heck are. Multiply fractions straight across. Because I have a subtraction sign there, we've got terms. So I'm going to go ahead and use my distributive property. 2 times 2 is 4. Right there, check. And 2 times minus 2 root 3 is minus 4 root 3. And in my denominator, 2 times 1 is 2. Yes, these are in fact the same. X is equal to 2 minus 2 root 3. Okay? And if when you're entering your answers on the computer, they have it set up. Let's go ahead and write these together. If there's an I, we don't have an I there, but if there's an I, the I is typed there. And if there's a square root, they've indicated that that's a space for you to write a square root. Everything is equal to itself over 1. Maybe I write that on a separate line. So when I'm going into my fields for my answers, you've got a space. They've written plus or minus. You've got a space. If there's, this one doesn't have an I. If there's an I, you've got the 2 spaces right there, but we just have the 1 space. And then you got a space sometimes in the denominator. And so I'm going to take this number 2, and that's what would go right there. The plus or minus is typed for me. 2 root 3, I'm going to put right there in that field box. Remember that little yellow arrow. Use it. If you use that, you can get the square root symbol. And if they gave you a box to put down here and your denominator is a 1, they do want you to go ahead and write a 1 just so the computer reads it. Okay? So let's look at this problem in summary. I know that's a lot. We modeled a lot of different things. Step 1. It's not set equal to 0. So what did we have to do? Like, they were baiting us with a mistake right here if you were just seeing sets of parentheses. You got to multiply this out. Then we're in the process of setting it equal to 0. You could jump in and just do the quadratic formula right away, but I wanted to model trying factoring in a strategic way and realizing that this equation was not factorable for us. That doesn't mean that there aren't solutions. That's why we need the quadratic formula. And so here I'm setting us up to use the quadratic formula. I just had it retyped. We identify A, B, and C. A is always the number with the x squared, B is always the number with the x, and C is the number by itself. We plug in, and then this is the kind of sticking point for a lot of us is doing this simplification. I recommend that when you, for sure, unless you've gotten really comfortable with simplifying square roots, go ahead and do that off to the side as some scratch. It's super, super common for students to want to just stop there and say that, well, it looks better. You need to, it's a fraction. In fact, it's 2 fractions. I wouldn't stop 20 30ths. I'd say, oh, that's 2/3 because I see a secret times 1 in the form of 10 over 10. I need to see that secret times 1. And that's all we're doing here. And I modeled it. It's not any different work, but I just modeled writing it a little bit different ways to kind of help different students. Okay?